What's up, Calcubats? In this video, we're going to go over something called logarithms. And up here, I have the way to transform any exponential into a logarithm. So I want you to pay close attention. N right here is our exponent. But if you look closely at the logarithm, it becomes the answer. So logarithms are used to solve for exponents when you don't know them. But I want you guys, and I want this to be really drilled into your head. Logarithms are exponents. Okay? It's like the inverse operation. Inverse of addition is subtraction. Inverse of division is multiplication. The inverse of logarithms is exponents, and of exponents is logarithms. But I want you to pay close attention that the logarithm becomes the exponent. That's what I meant when I say logarithms are exponents. Okay? And pay close attention to the placements of the variables. So x right here becomes the base of the logarithm. So right here, and it's little x. Okay, do not write it like this, log x. This is not how you write a logarithm. Okay, you have to write it log and the little x on the bottom. We call this the base of the logarithm. Okay, so this is log base x. It could be any number. If you look at numbers 2 and 4 on the left, it's log base 2 and log base 10. Okay, and the y right here, that's called the argument. And this n is the exponent. Exponent. Why does it do that? Exponent. Alright, so with all three pieces of the exponential on the left, we can turn it into a logarithm. So let's turn number 1 into a logarithm. So first things first, you write the word log. So this becomes log. What's the base going to be? Well, in this case, it's going to be 3. Log base 3. And what's going to be the argument for our logarithm? It's going to be 9. 9. And that's going to equal 2. Just like that. The exponent became the answer. Alright? Let's try the next one. This time we're going to work backwards and rewrite it as an exponent. Okay. So, in high school, my teacher taught it like this. He called it the snail method. You start at the base of the logarithm and you creep over like that. Boom. And he called it the snail method because he just put a little antenna right there and it looks sort of like a snail. So, the way you read this is 2, we follow it along, alright? Watch this. 2 to the power of 4 is 16. Follow the line. So we get 2 to the power of 4 is 16. Follow the little snail and you'll get to the transformation, the conversion of the logarithm into exponential. So 2 to the power of 4 is equal to 16. Let's rewrite this one right here. 5 to the power of 2 is 25. Well, logarithms are exponents, so our answer is going to be the exponent. In this case, it's going to be 2. Cool. So now we can write the word log. Log base what? We look at our conversion up top. It's going to be log base 5. And the argument is going to be 25. So log base 5 of 25 is equal to 2. And let's do the snail method for this one to rewrite it. 10 to the power of 3 is 1000. So this becomes 10 to the power of 3 is 1000. Pretty cool, huh? And we'll stop there for now.